As a reminder, please sign in on the attendees list in the working group meeting document attached to the invite. We'll get started in probably 3 minutes. All right, we're at about 5 after. For folks who haven't signed into the attendees list on the working group meeting doc, be great if you could do that. And I think we should just get started. Anything before we dive, any logistical stuff before we dive into the agenda today?
I guess just new faces, but that can probably be covered in the greenhouse thing.
Sounds good. I guess, Terrence, you want to do that introduction?
Sure. So we had a presentation from Cigna where they talked about how they were using Cloud and Buildpacks, and that went over pretty well. Luckily, this time we're recording stuff, so people can actually watch this one. So I've been talking to Paul and asked if he could do a presentation on how Greenhouse is using Cloud and Buildpacks, and he graciously agreed, and we decided to move it from last week to this week due to the holidays. And so I'll let him kick this off and introduce the rest of the team.
Cool, thank you. Hi, my name is Paul. With me and mostly on my team are Josh, Juan, Dana, Adam, and Mike. And yeah, if any of you want to say hi, feel free. But I won't make you. So I guess we can just get into it, I guess. We've been using Buildpacks for, I don't know, maybe a year now. So I don't know, we're not total novices with this thing. I just want to give a little context on kind of why we, like how we arrived at this, like how we came to use Buildpacks in the first place and we wanted out of that. And just for some like really big context, we kind of have a Heroku-like platform that we maintain for our product developers. And like Heroku, we need to build application images to run the code that our product developers are writing. We started making images in kind of like the most naive way possible, which is just doing Docker build. And we ended up with just a build server that ran Docker build. It was actually running Git, so you'd Git push to it, and then it would run Docker build for you. After a little while of doing that, we had a bunch of Ruby images, so we kind of wanted to not duplicate so much between all these very similar Ruby applications. So we extracted out a base image, a Ruby base image, and had all of our Ruby applications build in reference to that. But that proliferated a lot because then we had a lot of Ruby versions to support. Another problem besides image proliferation was that we had to go in and update the application repos every time we wanted to make a change to the, not every time, but frequently when we wanted to make a change to the base image. And that became kind of onerous, along with the bookkeeping of all the different versions of the base image floating around. So going along with this kind of big build box that we had sitting around, another issue with it was that we were running Docker build on it, which requires privileged access, and that's not a great thing. We were also in a Docker in Docker situation, which is also pretty generally undesirable. I guess unless you're developing with Docker. I mean, it can work, but you can get into some trouble, as we can tell you about if anyone really wants to know about weird Docker and Docker issues. We also had a few other kind of applications floating around, in maybe other programming, written in other programming languages, and we still had a lot of, even taking away the Ruby specific stuff, there was a lot of duplication with that. With like specific things that we needed to do inside of the images and while building images, so that the images could run and be understood by our deployment platform. So there was a lot of duplication there. And in general, like putting all this stuff into Docker files and application repo doesn't hide a lot from application developers, and we wanted to like put more of that burden on ourselves and like take it away from them. So things should just work when they want to build an image and they don't really have to know the details of it, other than how to set up their project so that it works, and then declare sensible things like what are its runtime dependencies. Yeah, so we wanted to, like, kind of at a high level, we wanted to take more control of image builds, and Heroku does a good job of this, right? I mean, Buildpacks coming from there, and we were familiar with Heroku as well, so we had that experience ourselves. And we kind of also wanted one of the other benefits of taking that upon ourselves is like uniformity. So we wanted like uniformity and consistency across these images without like all this duplication. We also wanted better Docker images. Our Docker images were pretty big. They like included runtime dependency, build time dependencies. And why was that? Well, at the time, I don't think multi-stage builds were available. Maybe with multi-stage builds today, you could work around this, but at the time, that wasn't an option for us. So, but we wanted to keep all of the layers, so that we could have some caching involved in our Docker builds, and so we didn't want to flatten our images. So we'd have all these layers that contained build time dependencies, and of course, even like doing RM in the Docker file doesn't have an effect on that. So getting build dependencies out of our Docker images would be good, and while retaining caching. Unprivileged builds were also very nice to have. We wanted that. Not having to maintain our proliferating base images would also be really good. Using upstream tools would also be a great selling point for using Buildpacks, and something that that attracted to us to Buildpacks as well. Yeah, with all that, I mean, we explored some options. I actually don't. I wish I could remember what else we looked at, but I don't. I didn't look at it myself in any case. Well, we hit up on Buildpacks, and I've been using that for about a year. Currently, like, the state of the art for us is we run everything on Kubernetes pretty much, or at least all the things that my team does. We run it all on Kubernetes. Part of our Kubernetes clusters, our Kubernetes clusters are set up with Argo, which is a kind of modern CI/CD tool for specifically built for Kubernetes. So our Docker, sorry, not our Docker builds, but our image builds run as workflows on Kubernetes, where it's just a bunch of stages. It looks pretty much like the build phases that you'd run anywhere. Analyze, restore, detect, analyze, restore, build, export, all that. Those are run in like their own containers in an Argo workflow. What else? Right now we have our own stack defined. This is kind of a legacy thing. We'd like to get away from this and move towards using Heroku's stack, but we haven't yet. That's it to do. Maintaining our own stack doesn't really guarantee compatibility with like upstream build packs that we might like to use. So that's one benefit. That would be one benefit of doing that. But our stack is pretty similar. It's nothing wild. And then as for build packs, the build packs that our stack supports are all written by us. They are mostly shell scripts, but we played around with libcmb and have a production build pack written in that. We are not at the point of using any upstream build packs, like I said, because we have our own little legacy stack. Most of our build packs are pretty simple. Like we don't do anything like I don't know what I would call like a meta build pack, where like one build pack is just defined in terms of the other build packs that like you want to drag into the build process. We don't do anything fancy like that. So to give an example, we have our Ruby build pack, which installs the Ruby runtime, does bundle install, configures the Ruby environment in some kind of ways that we like to, in some ways that we like. This is all done by one build pack, rather than maybe having a Ruby runtime build pack and a separate build pack for bundler, or rather even like a Maths Ruby interpreter build pack instead of like a, I don't know, JRuby build pack. I don't know. We only use MRI. One kind of interesting thing about this build pack is that it supports like having a secondary gem file and secondary bundle, because our app developers discovered that this was useful for doing large scale upgrades, like say upgrading Rails versions in a project that has many dependencies. So yeah, we have this nice little secondary gem file and bundle support. And really, all of our other build packs are kind of oriented like that. Not all of them, but we have a Node.js build pack that's the same thing: runtime and dependencies. Python, same thing. Clojure, Elixir. We also have a Golang build pack, which of course is not it was more about compiling the executables that we need to run. The executables that are the application. We also have a build pack for Rails assets. We're pretty Rails oriented, so we have a build pack that runs the Rails asset pipeline. And probably our other most interesting build pack is our apt build pack, which we use to install like arbitrary apt packages during the build phase. So an application can just say, I want all these packages. I don't know, like any kind of apt packages, and in like the usual like apt command line syntax of like name and version. And the build pack will go and try to install those. It's kind of neat and hacky. It uses apt to get the deed files, and then it uses dpackage to extract them to a layer. And usually everything works, but not every package expects to be handled that way, so it doesn't always work. And with all that, with all these in-house written build packs, we've been able to move all of our applications over to build packs, except for one, which has pretty complex runtime dependencies. It is a Python app that uses a Python library called Theano to, I don't know what it uses for, but Theano wants to, Theano basically takes Python code and compiles it to like translates it to C and compiles that at runtime. So it needs G++ at runtime, and satisfying that was really hard. So we haven't done that yet. But everything else went pretty smoothly. I guess another interesting thing about about the way we use Buildpacks is that we have a file. So our platform is called Dojoku, like Heroku, and we have a file called the Dojoku manifest, which all of our application repos that can be deployed to Dojoku have to carry around to say things about themselves, like here's my name, and here are the components that I run, analogous to like entries in a proc file. And in that Dojoku manifest, we have some keys and values that can communicate simple things to build packs, like say, oh, I want Node.js at runtime, or as in the example of the apt build pack that I gave before, like the list of the apt packages that it wants at runtime. Yeah, and hopefully that wasn't too much to say all at once. Would anyone else like to speak or have any questions about anything that I said?
You mentioned you use Argo to do Cloud Unit build pack builds. Do you have any examples of that, or tooling, or could you speak a little bit more about what that kind of looks like on your infrastructure?
Yeah. So we have a Kubernetes controller and some custom resources that we use to represent like builds at a higher level. But the builds themselves, when the controller sees a build resource that's pending, then it goes and creates an Argo workflow. And let me take a look at that. But while I'm pulling it up, the high level is it has to do a git pull to clone the app repo from GitHub. All of our stuff is hosted on GitHub, so it clones it from there. Geez, what else happens? I mean, it feels like right from there you can go into all the lifecycle build phases. I believe we passed. So because these build phases are all taking place in their own containers, we have to pass around like the layers directory and even the application repo directory as Argo artifacts. I guess you could do with volumes as well, but we use Argo artifacts.
Do you use Argo to sort of monitor for new build packs that you're producing or new stack images that are produced upstream, and like use that to sort of fan out to applications, or is it more imperative? Is it like you say, I want to build, and then it builds using the latest stuff?
yeah, it builds and it builds. It builds using the latest stuff really, and our stuff. We're not really checking for any upstream stuff. We have our builder image, and the Argo workflow just grabs that and does the build. Our builder image also has to define all the things that it expects to see is like a Ruby, a build pack, and maybe it's got Rails assets, and maybe it needs Node.js as part of that, or like a Golang application which will require the Golang build pack, and maybe we'll want some apt packages and things like that. That's all in our building.
You have an Argo workflow for rebasing. So if like you make a new stack image, will you then like rebase your production images, or do all the stack changes sort of flow through the build part of the pipeline?
Yeah, all the stack changes flow through the build part of the pipeline. We haven't had much of a use case for rebasing because we're building all the time. We do multiple production deployments to our main application every day. So yeah, if we need to roll out a change to the builder or to the stack rather, that change can make it to production very quickly.
On the VMware side, we wanted to create an experience where the end user doesn't have to think about updates that are flowing out to their app. It's like very declarative. Like here's the source code, and then it'll pick up the latest build pack and rebuild. When that's released, pick up latest stacks and rebuild it. That's released. And so we put together some CRDs and controllers in an open source project called KPack that's really focused on that sort of upstream monitoring. I was curious about, it seems like you build more of an imperative workflow, and your users are more interested in that. I was like curious if you looked at KPack or like what your motivations for using Argo and the way you used it were.
I can chime in there. I did look at KPack, and I'm trying to remember why I decided we couldn't use it. With the way that we're building images and tagging images, we're not ever really updating a latest tag for a particular image. We're always going to tag our images with the git commit SHA. So this sort of speaks to the rebase question as well. That's why we don't use the rebase, because we're always going to build a new image for new commits. Man, if you had asked me 6 months ago, I would have remembered for sure why I didn't use KPack. I did model some of the CRDs after those in KPack when we built the build controller. But yeah, I wish I had my notes from then, and I could give you a concrete answer.
And not trying to push you one direction or another, just curious about your kind of motivations and like what your kind of use cases for the life cycle were in K8s. But some of that's really good around needing to retag every time.
Can you say that you're not like pushing to the latest tag because you're tagging each image with the git SHA?
Mm-hmm.
I feel like a workflow that I've seen with cloud native build packs is sort of to use a single mutable tag to like track the identity of the application and then also apply like immutable tags like a git SHA to each image that you're generating. And I was wondering, do you guys do that? Like even if you're not consuming the latest, do you have like immutable tags that sort of like give you the like the head of a branch, for an analogy there?
Yeah, so we do maintain that latest mutable tag. I think the only thing that we're actually using it for is for caching purposes within the builds themselves.
That's what I was going to ask. I wanted to make sure you're getting the performance that comes from the knowing what the previous image was.
Yeah, so we do keep that tag updated, but it's only for build purposes. One of our major one of our use cases is that we want to have many copies of our applications running at one time in a sort of not quite production environment. I mean, we call it dev, but people are not developing against this environment, but it's they develop on their laptops. But when they want to deploy to a more production-like environment, they deploy to dev, and we have I don't know, something like 100 different copies of the recruiting application running at any one time. And they're all running, different versions of the code because they run everybody's branch. So that's the motivation behind like tagging with the Git shop.
I think KPack will support tagging each image separately, but not with any information from Git. And so that's interesting to hear for sure.
Could you walk through the workflow that will create build resources in Kubernetes? Are those just one-off resources? And when are they created?
Do you want to demo it, Paul? Or do you want me to demo it?
Yeah, we might as well.
All right. This will definitely work perfectly.
Cool. Wait, I gotta set up. I'm not on our VM. Yeah. Maybe I can get set up here and we can talk about other things in the meantime.
I had a question around your manifest file. Like, some of the stuff you talked about, we definitely don't support in Project Toml, but did you look at Project Toml when you were kind of designing the manifest file that you have for kind of configuring build and build packs and other things? And I guess from a project perspective, definitely interested in things we can do to upstream stuff to kind of support your use case as well.
I don't recall looking at Project Toml, but I think that was because, I mean, it's not the first time I'm hearing of this, but our manifest file was like the natural place to put this stuff. We've already got other things in there. We didn't design that just when we started using Buildpacks. Like that predated our move to Buildpacks by a few years. Like the existence of our the Joku platform manifest file.
It's something closer to like a proc file or how we use the proc file in Heroku. It kind of started by defining how we run different processes that make up the application, plus a few other elements. And so, yeah.
Definitely came up. Oh, sorry, go ahead.
I was gonna say, I feel like it's interesting because like one of the goals of Project Toml was that a bunch of platforms that all run Buildpacks could sort of unify like under an interface where an app could run on any of those platforms and still have, still using the same file. But I wonder if in the wild it's turning out that that is not a particularly realistic use case. It seems like everybody has platform specific features they want to layer on top, and not many apps actually would get pushed to any arbitrary one of these things. Something I've been thinking about.
Yeah, KPack doesn't use it.
I had I'm happy to keep asking questions if other people don't, but I also want to open the floor if other people have other questions.
I have a question to kind of fill in here a bit. So from a developer's perspective, like how much knowledge do they know of what's happening behind the scenes in regards to build packs, right? Because it seems like there's a certain team that's creating build packs and kind of setting up the infrastructure that manages all that. And then the app developers are more or less doing like product specific applications. So what does the overlap there look like, if at all?
That's correct. I mean, we wanted to take this knowledge away from them and like hide it from them, so that they, so like I said, they just have to know about how to, configure their Ruby application and say what its dependencies are, which of course you need to do in order to run your app anyway. Like even independent of build packs, you need to say those things. Like here's the version of Ruby that I want, and here's the version of all the dependencies that I want, and maybe here's the like OS packages that I want. So a lot of that is like, yeah, like just generic Ruby app configuration, which our build packs, know how to read and use. There's like we don't want there to be a lot that they have to know about how images are built. Like ideally, our builds just work and they don't have to think about it.
Cool. And do you know if they would essentially use like pack and then whatever builder you provide to run it locally, or are they just running it locally through their local environment setup?
They typically don't run like production like images locally. We don't have any like official support or or we don't like, our team doesn't like officially advocate doing that. I guess it's possible, but it's just not something that we do. It's typically things are just run from source, not in a container.
Cool, thank you.
I had a question along those lines of what Javier was asking, but probably more of like pre-Buildpacks. I guess like when you were doing stuff with Dockerfile, did the app developers take on owning like writing those Docker files? Was that something like the team that's kind of owning the Buildpacks and stuff today? Did they like kind of scaffold and set that up, or kind of like what was like the team composition, like errors, responsibilities for kind of managing that?
Yeah, they were, those Docker files were mostly written and maintained by the team that exists today, which maintains all this Buildpack stuff. But it was in the app repo, so app developers could also touch that at any time and do whatever they wanted with it. I don't know. Is there anything else more specific that any Greenhouse people remember about that era?
Well, we had this common base image for Ruby applications. So, and it used the feature. The feature is escaping me the name of it. Basically, in the parent Docker file, you can say run these commands when building
on build.
Child. On build, yes. So it took advantage of on build, so that the Docker files in the application repos were typically only a from line, and then maybe a couple of other statements. So there wasn't a lot of maintaining those, other than when we changed the upstream image that we had to force on all of the applications, we would have to open 15 pull requests to update those, which was not fun.
The on build statements or whatever, also some of them ran like arbitrary shell scripts that could do anything.
There's still a little
probably as root. What was that?
There's still a little bit of that. We still provide a couple of little hooks. So the big one would be pre-deploy. So we will run basically an arbitrary shell script during deployment that runs like before the rest of your workers roll out for things like database migrations or asset uploads and that kind of stuff.
Okay, so I think I'm ready to try this live demo. Let's see how it goes. Okay, so here I am. We have this this little app that we use to like exercise our platform, which, like I said, is called Dajoku. So that's why it's called Dajoku sample app. And you see this Dajoku build command. I'm just making a new commit. I'm assuming I've already built this one. I've already built an image for this SHA successfully, and we don't like to mutate image tags except for latest, where we have to take advantage of caching. We don't like to mutate image tags, especially where SHAs are concerned, and for images that might end up in production. We can tell you like scary stories of what happens when you use mutable image tags. But suffice to say, we don't do that. So I'm making a new commit, and I'm going to push it up to GitHub. And then that should be all we need to do this build. So let's give it a shot. I can also make this a little bigger. I don't know how big it needs to be. So I have this other terminal open down here because, no, oh, we renamed it. My bad. Okay, so now it'll work. I promise. I have this other terminal open down here because you know, in the top one we'll be able to see the output from the Dojoku CLI, and in the bottom one I can show you that like we're making resources in Kubernetes that are associated with these things. Hopefully. What happened?
The space. Do -s dev, I think is the problem.
I guess so. Okay.
Maybe, or, you know, this is just a live demo that's going as
I did this. I swear. There's still going to be some downtime even after this starts. You know, it's not going to complete in like 15 seconds. So please feel free to continue with any questions or I don't know, just statements people have, whatever feedback.
I had a question around, you're talking about the app build pack. I think at least definitely on the Heroku and I believe on the Pillow side, we also have experience with doing app build packs, and kind of the drawbacks or kind of things you have to take into account for app packages that don't work out of the box. There's been a lot of active discussion, I think, with the OS image extension thing that Stephen wrote, and then kind of the root build packs, and I guess we call them stack build packs, things that Joe has been working on. Have you had a chance to look at any of those? Like, we don't have any working implementations of stuff, but I think we're definitely really interested and curious from people kind of outside of these two groups of, does this help solve some of the needs that you're clearly trying to solve today? That's a little more hacky, like you said.
To add to that, you know, Cloud Foundry had an app build pack that would do that unpacking of packages, you know, into individual directories that we ran for a couple of years, but we never felt comfortable enough telling people to use it in production because too many packages would behave kind of unexpectedly. So also really interested to hear about if you've looked into some of the you know, apt RFCs. Oh, you're muted.
Sorry, am I unmuted now? Okay, I'm not familiar with any of that. I remember I looked at mixins and I kind of wanted mixins to like be the magic thing that gives me these OS packages, but I know it's not. But I was confused by that first for whatever reason.
That is sort of the interface we're trying to design now. For right now, mixins are the not so magic thing that tells you about the OS packages, but we're hoping to like then dynamically provide them at build time.
Yeah, dynamically providing them would be really sweet. Okay, so this build is happening, and we're getting logs. These are like just the names of containers. Or sorry, the names of pods, kind of what you would expect. This should also look pretty familiar. It's just detect and analyze and cache and all that. Analyze and restore. Oh, crap. So we have this custom resource, and I was just going into that because it has the name of the Argo workflow that is doing all this work. Yeah, and I wish I had shown you before, but these didn't exist. I wouldn't have been able to show you because these have like generated names, and you know I don't know what the name's going to be.
Did Joku push command actually create this resource in the cluster?
Yeah, the Joku push command created our custom resource, an instance of our custom build resource. and it's the build resource. It's pretty simple. It just tells it just has information about what repo this is concerning and what git commit SHA we want to build for, and also the status of that build, like if it's running or if it succeeded or failed for whatever reason. So we have a controller that looks at those build resources and makes a workflow in response to that. Did that answer your question?
Yeah, I did.
Okay, so what happened here? Everything went by as Matt and I were talking. So we've got our Ruby build pack. This is, I don't know, I tried to model the output after what I was seeing from pack itself. So got layers of indentation to communicate, segments of the build pack. And that's really all this app does. It pretty much only needs Ruby, so that's all we do. And then this one down here is like our what is it? It's setting everything up so that we can use a CMD process type, that environment variable, to just pass that environment variable and then have the container do whatever its job happens to be.
Do you want to show the Dijoku manifest file?
Yeah. Okay, and now we have down here as well. The custom resource has a phase column. The output has a phase column, and it succeeded. Whereas before, it was running. Cool. Maybe it took like around 3 minutes or something like that. So here we can check out this. I don't know what the best way to look at this is. Maybe JQ. I don't know. Because at least it's colored this way. Yeah. So this we have this components. Maybe YAML is actually better to look at. So there's some kind of like generic things that we want to know, like what is the name of this application. When we were migrating to Buildpacks, this was useful. I think we can actually delete this now, so we should. Here is the components key, which defines all those things that get and this is the part that's analogous to the proc file. All these command attributes are what we use to we translate this into the format that so that we can use it with a CMD process type. These are all the commands that end up being run according to the value of CMD process type. And this being Kubernetes, I don't know, we have some things that just translate into Kubernetes stuff like health checks and upgrade strategy, things like that. Was there anything else interesting that you wanted to point out in here, Dan?
Probably not that's relevant to Buildpacks.
Yeah, there's actually
There's a bunch
more.
of other stuff for.
Yeah, this file got much more busy, got a lot busier in like the past month or so.
Yeah, we started adding firewall rules and stuff like that to this.
Do you pass any buildpack config to the buildpacks through this file? Like, do the buildpacks at all parse this besides for the launch commands here?
Yeah. The detect executables can check in here for things. If the apt buildpack does that, it checks this file to see what are the apt packages that I want. And we have it's a build pack that translates this command bundle exec blah 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 into the I forget what the file is called.
The launch toml.
Yeah, that translates that into the launch toml, so it has to read that as well. But we don't like to. This really should only be read at detect time, and then whatever we need from it can get passed like via the plan to the build. Does that answer your question?
Yeah. So all this happens at detect then, and then you put them into the build plan.
I don't want to. I don't think that we do that 100% across the board, but yeah, like ideally.
I know in the past you've mentioned like traceability or reproducibility of builds as a pain point or something you'd like to see fixed in the project. Beyond that, like if you had a wish list of things that would make your lives easier in the adoption of Buildpack, what stands out?
The first thing that came to mind was that like if one of the application teams is working on a Ruby runtime upgrade, from like some minor version to another minor version, while they're developing that and deploying it and making images, the cache gets thrashed because like someone will build with like Ruby 2.6 X and someone builds with 2.7 Y, and every time you alternate that, the whole Ruby cache gets invalidated. So I don't know if it. We can definitely work around this ourselves. Like if we were like identifying application images in a different way, we could solve that problem for ourselves. But it seems like we'd have to do some lifting, so we haven't done it yet. I don't know if that's something that.
Like for at least the gems and stuff, I know if you're upgrading the Ruby, if you're changing the ABI of it, it puts in a different directory. So in theory, you could actually keep the same cache, I believe.
I don't know that was what I meant. I mean more like when we, if we're going along and doing 2.6.5 build after 2.6.5 build and no one changes any gems, like the whole Ruby build it's all using cache results. But since someone comes along and does like 2.7.1, the 2.7.1 image will become latest, and then the next 2.6.5 build that someone tries to do won't be able to use any cache. Like we could make this a little smarter by like knowing, oh, this is a Ruby, by instead of pushing latest, we could push like latest 2.6.5. And then, when we do a 2.6.5 build, we have to reference that as the image that we're building against and the image that we're going to export later. But we don't. We just do latest. Does that kind of clarify?
Yeah, I guess in the build pack, easy hack that you could do is because the gems are segregated by the ABI version that Ruby's using. So like Ruby will say, like if in your gems directory, there will be like 2.6 because that's the ABI for 2.6. It'll actually install the gems in a separate directory than 2.7. If you don't actually clear that directory, you could leverage that same cache directory for both versions of Ruby. I assume your build pack is actually clearing the cache though.
I think it's been a while since I looked at it. I think if you change the version of Ruby, we're going to throw away the layer that has the Ruby install, and then also the gem layer as well, which we may have copied from the example Ruby build pack on the website.
Yeah, I mean, that's what we do at Heroku for sure.
Yeah.
I guess as a point of reference, I maintained the Ruby build pack for Heroku for like 8 years. So I have some experience doing it. And that's something we do because you don't want the caches to grow indefinitely either. So like that's kind of the trade-off. But if this is a problem you're having, you could in theory, like not for the runtime, but for the gems, at least not clear that cache, or make sure to only clear it like every, I don't know, like 3 ABI versions or something. If that's like a big pain point for you. I know it's not like a CMB specific fix, but it is a thing you could do in your build pack, I think, to help mitigate that pain point.
One thing we were talking about yesterday, mostly in the context of pack, is sort of how we use the image tag, like a single mutable image tag, to sort of stand in for image identity, right? So like you were saying, if you had 2 different mutable tags for these different things, you could get around the thrashing, but I wonder if we need to, if that interface is very unintuitive, it's like not something that people naturally gravitate towards in a way, and like maybe there's something we could do differently there. But I guess the platform itself is, because we're not talking about pack, your platform built on top of Argo is deciding which images are sort of in a stream that they would get the same cache, right? Probably based on the tag, I would imagine.
Yeah, I think we base it on the Git repo that gets passed to the build, but same idea.
I have a comment on something that was said earlier, not really a question. You mentioned wanting to move towards a stack ID that would work with more build packs, or stack images that would work with more build packs. We did a while ago unify on a stack ID for everything that's Ubuntu Bionic based, so that you can have your own stack and other build packs will work on it. That I linked the kind of description of what that looks like there, if it's helpful. And that would kind of solve your interoperability problem, because we want to solve that for across VMware and Heroku also. It's definitely a big goal.
Thanks. Oh, nice. The dynamic mix in RFC is in there too.
Yeah, I linked that earlier.
I had a question on just like how you as a team keep up with changes in CMB, or do you, or like how often do you update lifecycle as releases and stuff come out for your platform?
Lazily, we went a few major, not major. I mean, they sometimes it can feel like major versions, but we went a few like minor lifecycle versions without doing anything. But did we go from like 4 to 8 or something like that? And we're probably on 8 now.
Yeah, it seems to be when we reach for the docs and then happen to realize, oh, there's a new release or 6 new releases. Maybe we should upgrade.
One thing they've recently approved as an RFC is that now platforms will be able to set like a CMB platform API environment variable, which will then configure sort of the version of the interface using for the lifecycle. So one thing I'd be interested in is like once the next version of the lifecycle comes out that supports that, if you find it easier to update, because then you can keep pulling in new ones, but if you don't change that variable, you should get the same behavior, and then you can sort of upgrade the version of the API you're doing while not coupling that to upgrading the lifecycle code. So you'd still get like performance and bug fixes and stuff like that.
Yeah, that sounds useful.
Have the lifecycle upgrades been painful, or is it mostly seamless for your team?
I mean, the last one I did was, like I said, from like 0.4 to 0.8, and I broke build caching in the process, and I had to fix it. Because I knew that export and cache were consolidated, and I knew that analyze and restore were reversed, but there was something I missed, and I don't know, I broke caching. I don't know. It's not something that we've done that I've done like often enough to make like generalizations about it. But I don't think that we were holding off on it because we were like afraid, or anything like that.
A question about your app build pack. Have you run into problems with the strategy of, or like, and if you've run into problems, what particular things have been painful about your strategy of extracting app packages into the layer directories with different absolute paths?
I mean, what problem haven't we run into? I think, like, it seems to be a surprise that it works as well as it does. I don't know, Paul, like we've certainly seen lots of broken symlinks. I think I think I got a PR merged in Buildpacks to like not blow up when you encounter a broken symlink, something like that. That was for this. And just, you know, things, there's lots of things that just expect their files to be in a certain place. And when they're in a different place, they're just not going to work. I think what we ended up doing this other build pack, which we called like custom packages to like work around this. Yeah, Juan's nodding his head because it was a lot of fun. Where we basically, I'm trying to remember how it works because we haven't had to really touch it because really only one app uses it. But we have this app that's doing document conversion using LibreOffice, which is finicky about, you know, where its files are. And I think we compiled it. We had to basically compile a package, and you know we tar it up and stick it on S3 somewhere, and then all the custom packages Buildpack does is look for that package at that particular version on S3 and download it and untar it. Something like that. And you just have to compile it to go into the layer directory that it expects to be in.
It'd be really great to get your feedback on the application mix and stuff, because I think this has been like a large thing for a long time that people have wanted a solution to. So I was curious. It seems like you've run into some sort of very similar things that other people have. You know, I think Heroku had an app build pack that was kind of like that for a while. You know, Cloud Foundry did. It'd be really great to find something that solves a problem.
Yeah, I guess someone on that note, is there a good way, or what is the best way to kind of engage you and kind of the team? Like, it's really insightful. Like, these sessions are really insightful and valuable. So thank you for doing it as we're coming up on closing. So I really appreciate all of you taking the time to do this. But is there a good way to kind of engage you on certain RFCs that we think we would love your input more on? So maybe you don't have to kind of keep track of everything that happens because there's a lot of stuff that flows through RFCs, or what's the best way to kind of engage the rest of the Greenhouse team for getting input on things as active users of the project?
I don't know. Tag us on GitHub, I guess. We could relay some of our GitHub handles. I know I was on the Slack or the Buildpack Slack for a while until I reinstalled things on my computer and didn't rejoin, but I can get back in there. Paul, I know you're on the Buildpack Slack, right? Pretty regularly.
Yeah, and you know, speaking for myself here, you know, you can just hit me up there and respond.
All right. I think we're about at time. This was really great, and I think a lot of the feedback that you've kind of provided here will let us figure out how to include you more in things that you're interested in on GitHub. So you know, I'm you know, excited about collaborating in the future if you guys have the bandwidth to do that. Any other questions for anybody? I know we're at time right now. Thanks.